Hello, welcome to another lovely video here of AP Pre-Calculus. We're going to go over 1.2 rates of change. Don't forget to like and subscribe. Okay, so rates of change. We're going to talk about the average rate of change. You will need a calculator for this, so I'll give you a quick minute to get out your calculator. Okay, long enough. So rate of change. The average rate of change is the ratio of the change in output values to the change in the input values. Last time we talked about what output and input values are. Output is Y, input is X. So really, average rate of change. Average rate of change is equal to the change in Y, that delta means change in Y over change in X, which is the same thing as y2 minus y1 over x2 minus x1. These are all the same things. Or if you're in function notation, f of b minus f of a all over b minus a. Okay, those are three different ways to represent average rate of change. So for the first example here, we have a table that gives us output values of function f with selected input values of x. Find the average rate of change from 0 to 4. So for this one right here, we're going to do the average ROC, if you don't mind those abbreviations, is going to be f of 4 minus f of 0 all over 4 minus 0. F of 4 I see here is 5 minus f of 0 I see here is negative 2. All over 4 minus 0 is just 4. 5 minus negative 2 is going to be 7 over 4 is my average rate of change in that table. So this one didn't require a calculator, but we're going to get to now having problems with the calculator. I'm going to show you a lot of new calculator tricks, possibly new, or maybe it's old. So here we go. Here's our calculator example. The height of an object is dropped from a platform, and I'm right here, by the way. This example, the height of the object is dropped from a platform is given by this h of t. Let's go ahead and highlight that because that's going to be important for us. Where h is measured in feet, t is measured in seconds. Find the average rate of change of the height from the object from t equals 2 to t equals 4. So all we're doing here is we are finding the average rate of change. And that's going to equal h of 4. Oh, that's not very good looking. Let's try this again. H of 4 minus h of 2 all over 4 minus 2. Now, I'm going to teach you real quick how to use the calculator to make this look exactly like that. So, no, I don't want full screen. Okay, so first thing I'm going to do is I'm going to go to my y equals button, which is up here upper left, and type in that exact thing right there. Now, please be careful and do not type in the minus sign for that negative. The calculator has a minus sign and a negative sign. They mean different things. So be careful. If you're getting an error, I bet you it's because you're using the wrong minus sign versus a negative sign. So negative 16, minus sign, or sorry, the negative sign is down here below the 3. Negative 16. Calculator doesn't have t's, but we do have x's. So same difference here. Minus. So this is a minus because it's between the numbers. If it's a leading coefficient, we have to use the negative. 12 t or x in this case plus 25. Okay, get that in your calculator, and life is going to be pretty easy moving forward here. If you hit second quit, that's this blue button right here, activates all the other blue buttons. You hit second mode, which is quit, and the blue buttons. Go back to the home screen. I'm going to show you one other thing real quick before I actually solve this on the calculator. I said the second button activates all these blue buttons. Well, if you notice, there are some green buttons as well, and that's going to be activated by this alpha. So if you hit alpha and then math right below it, it's going to produce an A. Okay, we don't need that for right now, but I wanted to show you that for any time we use the green button. Now I want to activate this F4 button. That actually has something important for me. So alpha trace, which is the F4, activates these Y's. So we have Y1, Y2, Y3. Well, we already activated Y1 because we typed in Y1. So that's just telling the calculator, oh, everything we just typed in right there is going to match. So second quit. So if I do a parentheses like this, and just for fun, type in a 1, it's going to type a 1 into Y1 and bam, give me a correct answer of -3. So we're going to be utilizing this information in this button to type in exactly what we see right there. One more trick here. If you go to alpha F1, by the way, all of these have nice little things for us that we can use. I guess F5 doesn't work. But anyway, alpha F1 is going to, if you choose the first one, it gives us a fraction. Okay, and I'm going to type in h of 4. In the calculator, though, it's going to be y1 of 4. So parentheses 4. And then minus y1 of 2. All over 4 minus 2. And this is going to give me my perfectly awesome correct answer. Boom. So I get an answer of -108. Okay, you see how this right here matches this right down here? So I don't want to see. So this is going to equal -108. Now, I real quickly want to talk about the units. Technically, if I'm looking at the h values, that gives me height, which is feet. So the numerator is feet, and the denominator is the t values, which is seconds. So the average rate of change is going to be feet per second. Okay. That's it. It's going to take a lot of practice for you to understand how to do rate of change on the calculator. And don't worry, we have a lot more practice coming up right here. A positive rate of change indicates that one quantity increases or decreases as the other quantity does the same. Negative rate of change indicates that one quantity increases, the other one decreases. And a rate of change to a point can be approximated by the average rate of changes over a small interval containing a point. So we're actually going to hone in on this one right here, this average rate of change at a point. We're going to approximate the rate of change of this function that we just did, that we just typed in. We're going to estimate the rate of change of this function that I highlighted over here at 2. How do we do that? Well, let's find the average rate of change as we approach 2. So if I find the average rate of change, so by the way, this function, I can actually pull it up on the other calculator. So this function, if I wanted to see what the graph looks like, it's like this right here. And if I hit trace, I can kind of trace along it. So if I go to x equals 2, it's kind of hard. It's going to get really close, though. Change my window a little bit. Go from 0 to 4. Just playing around with this window a little bit so I can kind of see this graph a little bit. All right, boom, there we go. So if I trace, actually I don't think I went far over enough. Trial and error here. Go -100. Okay. I want to find the average rate of change at this 2. So what I'm going to do here is I'm going to estimate the average rate of change from this point to this point right here. Okay, so I'll kind of draw that out for you, what I'm trying to accomplish. So here's the graph right here that they just showed us. I want to find the exact rate of change right here at 2. Well, in order to do that, I need to estimate the rate of change from here to here. That's going to give me an estimate in green. Now, if I can get closer, 2 points in purple that are closer on the graph, that's going to give me more accurate rate of change. So it's all I'm doing for this problem is finding 4 different rates of change as those intervals get smaller and smaller and smaller. So let's go back to our handy dandy calculator here. And one other trick I'm going to show you is we're using the same function, which is super nice. If you actually press up twice and hit enter, it's like a copy and paste. So I'm going to go ahead and change that 4 to a 2.5. I'm actually going to change this 4 right here to 2.5. I'll show you this too. If you, instead of me writing over everything, it's going to start deleting everything. If you hit second insert, it will write in front of what you have. And then I'll just highlight what I want and delete it. So the rate of change for this right here is going to be negative 84. Okay. Do the same thing for 2.1. I'm going to get negative 77.6. Do the same thing again, but now 0.01. So now our interval is super small. Insert a 0 in front of that. So this is going to be negative 76.16. Last time here, I'm going to insert one more 0. And this should be pretty accurate for my actual rate of change. And this is going to be negative 76.016. So looking at all these values, now this is approaching. So this should be getting closer to my actual answer. So I started at negative 84, and I moved a little bit closer to it, a little bit closer, a little bit closer. Oh, there should be a negative in front right here. So my rate of change I'm going to estimate is the approximate rate of change, ROC, as I'm going to say that it's getting closer and closer to negative 76. And this is going to be feet per second. Okay, so since we have an object and we have feet and then we have time, which is going to be seconds, this is actually going to be our velocity. So we're approximating what the velocity is of this object that's being dropped. Okay, so it gets closer and closer to negative 76. Okay, and that actually wraps up this lesson, and that is it.